Okay, here's an interesting question. We have a conversion lens of an index of refraction of 1.5 and having a focal length of 50 centimeters when in air. We would like to find its focal length when we immerse it in water. Okay. To do that, remember the equation, the only equation that we have and that we can use to find the effect of the index of refraction of the medium on the focal length is the lens maker equation. It is this equation here. That's the only equation that we use where the index of refraction of the medium and the index of refraction of the glass play a role in determining the focal length of the lens. Okay, so what I'm going to do, I'm going to rewrite that equation on our example page. So we have 1 over f is equal to ng minus n medium over n medium times 1 over r1 minus 1 over r2. Okay, now we know the focal length when it is in air. So let's write the equation for when it is on air. So this is f air. That's going to be ng, which is in this case just n, the 1.5, minus 1 over 1 times 1 over r1 minus 1 over r2. Okay, and let's write down the equation, the same equation, but for water. F water is equal to n, it's the same n, minus n water over n water times 1 over r1 minus 1 over r2. Now, we are trying to find F water. To do that, what I'm going to do is use a little trick. We have these unknowns that we would like to get rid of. You see, when you look at these equations, you notice that we can get rid of them if we divide these equations by each other. Okay, which means I divide this side by this side and this side by this side. So what does that give me? 1 over FA over 1 over FW, that's equal n minus 1 over n minus NW over NW. The terms in 1 over R1 minus 1 over R2 cancel out. Okay, now this is wonderful because it makes things easier for us. And the term on the left side that gives us F water over FA is equal, then rewrite in the equation, NW times n minus 1 over n minus NW. And we just plug in our values now. So we have NW, remember, is 1.33. Let me rewrite it here. So I have FW over F air, which is 0.5 meters, is going to be equal to NW 1.33 times 1.5 minus 1 over 1.5 minus 1.33. So this is equal 1.33 times 0.5 over 1.5 minus 1.33, that gives us 0.70. And then we solve for our focal length from there. So our F is 1.96 meters. You see, it's a much larger focal length because the lens does not focus as well. That's F water, by the way. Okay, let's discuss this other question. We have glass of a refractive index of 1.5 is used to make a plano concave lens of focal length 50 centimeters in air. What should be the radius of curvature of the curved surface? So it's a plano convex lens. So this is the kind of lens that we have. And we are asked to find the radius of curvature of that surface, R1, when we use the lens in air. Okay, again, the focal length equation using the lens maker equation is going to be n of the glass minus n of the air, which is 1 in this case, over n of the air, which is 1, times 1 over R1 minus 1 over R2. Now, since this side is flat, R2 is infinite. So which means my equation becomes 1 over F is equal to N times, N minus 1, sorry about that, times 1 over R1. If I'm solving for R1, it's just then R1, I multiply both sides by R1 and then multiply both sides by F. So R1 is going to be equal to N minus 1 times F. So in this case, N minus 1 is 0.5 times F, which is also 0.5 meters. So it's 0.25 meters or 25 centimeters. That's our answer.